Hey guys, welcome to our first distance learning class. So we are going to be starting by reviewing the content of this unit so far. And it might be an experience because this is also our first class. So hopefully I'm going to walk you through it. And if there's any need for any questions, just make sure you send me a Google Hangout if it's during class time, otherwise a detailed email. So I'm asking you for the do now to find the slope, which is the steepness of the line, which is calculated by finding the ratio in the change in rise, which is the y, to the change in x. Now, I'm also asking you to pay close attention to how you're going to upload your answers. We're going to do 2 of these 8 together, and then you're going to do the other 6 and upload the answers. So I'm going to start with question 1. Now, as a reminder, we use m to represent slope, and ratio results in a fraction. Now, a nice strategy to use is to label our points. Now, I labeled it x1, y1. The 1's go together. x2, y2. The 2's go together. And then order matters. Either I do 2 minus 1's or the 1's minus the 2, but I have to keep the same order. Now, remember, once I put that little 1 or 2 next to the y and x, it's no longer a variable. They actually represent something. x1 represents 19. So I'm going to do y2 minus y1. So negative 6 minus 17. That means I'm going to have to do x2 minus x1. This results in negative 23 over negative 6, which is 23/6. Now, when you write this as an answer in the system, you would write it as 23/6. If there's a negative sign, put it out front. If it's an integer, like negative 4 or 3, just write that number. You don't have to put it over 1. The next one I'm going to do is question number 6. And the reason I'm going to do 6 is we can actually just use the other strategy of counting. Now, our rise is 1, 2, 3, 4. But down, so negative. You could have started from here and gone up 4. And then my run here is 1, 2, 3, 4, 5, 6. If I had gone this way, it would have been backwards 6. Either way, it results in negative 2/3. Notice that I simplified my answer. Make sure you simplify when you substitute it into the program. So at this moment, I'm going to take a moment and pause the system so that you're able to do the other 6. Don't forget to message me if you get stuck. Okay, so as you've seen, I've written in the 6 other slopes. Now, you might have had difficulty with 3 and 8 or 4 and 7. And that's something we touched upon at the end there, but we're going to go into more detail today. 0 divided by any number, like in 3 and 8, is 0. 12 goes into 0 0 times. But 4 and 7 are more difficult because what the division says is how many times does 0 go into 17? Well, that doesn't make sense. And so we define it as undefined. We don't know how to give the answer to that. But again, as I said, we'll go into that a little bit more. Now, before we get there, though, let's make sure we know today's objectives. There are 3. Review the material we learned so far this unit. If you want to think about what that is, it's dealing with intercepts, dealing with slope, dealing with graphing, and part of graphing that we've been dealing with is domain and range. Domain, the set of all outputs, and range, the set of all inputs. We're then going to learn more about the 2 special cases And we're also going to notice a pattern in the examples that we began in Desmos right before break. All right, let's go on. So here are our special cases. What do they look like graphed? What are the slopes of them? And what do the equations look like? So let's go here. Let's make it thicker. Here, I'm going to graph a vertical line, say, crossing through the x-axis at 7. Now, you should be adding this to your notes as a reminder. I'm then going to do a horizontal line at -5, where it crosses at -5. So this is what a vertical line, horizontal line looks like. And now let's think about the slope. Well, the slope for a vertical line, well, it's the ratio of rise. Well, it doesn't matter which points we pick, but there's always a rise for vertical lines. But there's never a run. So the run is 0. Well, we just saw we can't divide by 0. So the slope of all vertical lines is undefined. Well, horizontal, on the other hand, the rise is always 0. And the run, well, there's many runs. You could do a run of 2, a run of 4. So we'll just write run. Well, 0 divided by anything is 0. So all horizontal lines have a slope of 0. So let's take a look at what the equations look like. Well, let's think about some of the points here. Well, some of the points are 7, 2. Another ordered pair is 7, -5, or 7, -7. Well, what do they all have in common? Well, what they all have in common is x is 7, x is 7, x is 7. So it turns out the equation is x equals 7. So as long as x is 7, it's going to be that ordered pair. And that's similar here. Down here, we have, say, the point 4, -5. We have 5, -5. We have 6, -5. And again, what's in common here? The y is always -5. So therefore, the equation is y equals -5. Now, I'm actually going to talk about domain and range real quick with these. Well, domain are set of all inputs. So our set of all x values. Well, for my vertical line, what do we notice again? Well, the x is always 7. So what's my domain? X equals 7. Okay, let's take a look at horizontal. Well, do we have an x that's 4? Yeah. Do we have an x that's -7? Yeah. Do we have an x that's going to be all the way down here? Yeah. So it's all real numbers. As a reminder, that shape, that R with the 2, means all real numbers. Now let's take a look at range for both. Well, it ends up just being opposite. The range for vertical line has all y values, while the range for horizontal line only has the one value, in this case, -5. So how do we generalize this? The equation for a vertical line, it's x equals b. And for horizontal lines, it's y equals b, where b is a constant. So that's some of our old vocabulary, constant. It's just a number, 3, 7, -500. So that is our general case. If you need to pause the video to take these notes, feel free to do so. What we're going to do now, though, is I'm going to scroll down, and I have 2 special cases for you to graph. So again, I'm going to pause the video and give you a moment to do these in your notebook. Okay, so there's the answer to those 2 graphs. I also put in domain and range because it can't hurt to see it and review it again. I'll remind you, if you have any questions, just send me a Google Hangout. Now, let's review intercepts and graphing. So for this example, I'm asking you to algebraically calculate the intercepts, then using the intercepts, algebraically calculate the slope, and then graph the function. So let's go through this. So I'm going to start by finding the y-intercept. Well, the y-intercept, what we saw before break, was when the x value was 0, and we're looking for the y value. So let's go and we say y equals -2 times 0 plus 8. That's y equals 8. So my y-intercept is 0, 8. My x-intercept is when the y is 0 and I'm looking for the x. Okay, so 0 equals -2x plus 8 minus 8. -8 equals -2x. Divide by -2, and I get x equals 4. So that is my x-intercept. So that's step 1. Using the intercepts, we're now going to do slope. So this is reviewing slope again. I'm just going to label x1, y1, x2, y2. I'm going to do y, in this case, y1 minus y2. So I'm going to say 8 minus 0. So that means I do 0 minus 4. I get 8 over -4. I get -2 as my slope. Well, I only need 2 points to graph. Let's graph this now. So I'm going to go here, and we have 4, 0. There's my x-intercept. And we have 0, 8. There's my y-intercept. And I graph. Don't forget those arrows at the end. And so this is an example to review. And now, again, if needed, pause it. But I'm now going to scroll down and going to give you the 2 practice questions. Now notice that I say your exit ticket will be to take a photo of your notebook where all of the work should be neatly shown. So I said that at the beginning. This is now your reminder. So I expect to see the algebraic work that results in the intercepts. Using those intercepts to algebraically calculate the slope. So we're not graphing and then counting. I want algebraic, and then graph the function. So I'm going to pause the video at this moment for you to work on that. So here are the answers to those 2 practice questions. Notice that for the intercepts, I write them as ordered pairs. Here are my slopes. There are my graphs. Now, you should be using Desmos to check yourself at all times as well. Now notice with Desmos, when I took a screenshot, it doesn't have the arrows on it, but I expect you to draw the arrows if they need it to continue infinitely. We'll deal with word problems that might not need arrows. Okay. So let's see if we noticed a pattern. These were the 3 practice problems. Well, the 1 example, and then the 2 practice problems. Well, we have a y-intercept of 0, 8. We calculated 8. Positive 8. We then had a y-intercept of -1. -1. You then calculated an intercept of -15. There's -15. Well, then from there, I then had you calculate the slope. Well, we found the slope was -2. The coefficient of x is -2. We found a slope of -1/3. Well, the coefficient of x is negative 1/3. Then I had you calculate the slope of the third one, which was 5/2. And the coefficient of x was 5/2. This is no coincidence. All three of these equations are in what's called slope, because they have the slope in them, intercept, because all three of them have the y-intercept, form. Mathematicians were not always that creative. So the form gives us the slope, gives us the y-intercept. Let's call it slope-intercept. And so when it's in this form, we can just look and say, hey, that's the slope. Hey, that's the y-intercept. We can just graph. We can just graph. I can just take a look at, say, the second one, my y-intercept. Let's just get some points up there. And I can just use the fact, there's my y-intercept of -1. The slope says down 1 over 1, 2, 3, because that's rise over run. You could have done it the other way and said up 1, back 1, 2, 3. There's my graph. I no longer had to calculate anything algebraically. And this was the pattern I was hoping that we'd start to observe. And some of us were starting to see that. And so we're going to go into more detail on slope-intercept form in the next class. Before the moment, I just want us to know that this form exists and that this form always tells us this important information. So I'm going to scroll down to the form now. The form, slope-intercept form, is y equals mx plus b. Well, m, you should hopefully be familiar, already represents the slope. And we use b to represent the y-intercept. Then we have x and y, which represents the ordered pairs, the infinite ordered pairs. So I just want to take a moment. These, the x and y, these are our variables. These two are actually placeholders, because a variable is going to be something that can change. Our slope is our slope. Our y-intercept is our y-intercept. They aren't changing. Once we find them, they replace the m and the b, and that's final. The x and the y then stay as x and y. So, as I said, your exit ticket is to upload a photo of your notebook. Now, you're going to be doing this through Google Classroom. You'll find under the assignment sheet, under the unit, where I'm asking you to do that. So all the instructions are on the assignment sheet, and it's going to be under that unit tab. If you have any questions on how to do that, just message me on Google Hangout. Hope this went well, and I'll see you guys tomorrow.